Welcome to Bungalows for Bachelors. Let's get right into it. We need to calculate the stuff we got drawn out in here first. So we're going to start with our beams because that's what we should just start with. And we're going to start in the front because I want to. And I'm going to take a look at this porch here. Okay, so we got a left beam and a right beam and a front beam. Left beam and right beam are doing the same thing. Well, the whole thing's the same amount of weight at least because the little truss dude that we built out of the ceiling joist and the roof rafters is sitting on the left beam and it's sitting on the right beam. And it's symmetrical, so it's doing the same amount of work. So we're only going to design and do math for one of them and copy that label over and say the other one is good for that as well. So that's what we're going to do. And the front one isn't going to be holding very much, just a little bit of roof overhang and some stuff like that. So we'll deal with him separately. But first thing we got to do is jump over to Forte Web, where I've got the level 2 house in here. I'm going to leave level 2 as it is. Exposure category B. Main roof height of this guy is an 8-foot ceiling plus 6 feet cut in half is 8 plus 3, which is 11 feet. All right. Residential. Awesome. Building class. Yep. Good stuff. So the first thing I need is a beam, floor drop beam. This is actually a drop beam because we're dropping it down below the ceiling. But we are going to call this front porch front back. FB front back, which means we are designing the beam that runs front to back, and they're the same. So we're going to just pick one of them. All right. So first thing to do is check these settings. System floor dropping grade, code minimum. Yeah, this is cool. That's good. Looks like this layout of this changed a little bit. Interesting. Okay, yeah, this is fine. Leave all, so I'll leave this all alone. Okay. So spans and supports. Let's define this beam. What is the span of my beam? Well, I'll go back to here and I'll take a look here, and it looks like the porch comes out 6 feet from the face of the house. So that means my span, and that's from the outside of the framing. So my span would be 6 feet minus the size of my post. And this is a 4x4 post, so let's just say it's 4 inches. And actually, well, it'll be a 3.5-inch post most likely, so let's not do that. Let's say, well, it's not, the span of this is not going to matter at this short of a length, so we're just going to call it 6 feet, and I'm going to be conservative. Is it actually spanning 6 feet? No, it's spanning less, but we're going to call it 6 feet because it's always better to be conservative and be stronger. All right, so I got a 6-foot span. Support 1. So whenever you're looking at beams in a plan like this, you always want to look at them the same way you would read the title block and the same way you'd read all the other text in the plan that's horizontal like this, right? You'll go over here to the title block. I would have to turn this paper and look at it from the right side to read those words. So I'm going to look at this house from this side, from the right direction. So support 1 would be the left side and support 2 would be the right side. Okay. So support 1 is the left side, which is not 3.5 inches. Well, it is 3.5 inches, but it's not a stud wall. It is a column, probably made of southern pine. And it's going to have lateral support. It's not going to have blocking, but it's going to be laterally supported at that side. And the other side is going to be technically inside the wall instead of sitting on top of the wall, but it's a stud wall. Spruce pine fir is great blocking. Yes, it'll be laterally supported on the ends. Cool. Top edge bracing is going to have those ceiling joists sitting on top of it every 2 feet. The bottom edge is going to be end supports only. It's just sitting out there. Loads. All right. What loads do we got? Well, this one's pretty simple here. Okay. So there's no point loads. There's no, you could consider each ceiling joist and rafter to be point load, but that's a uniform load for what we do, what we talk about here. So how much ceiling are we carrying? Let's deal with the ceiling first. Okay. So the ceiling will be the center of this to the end of the ceiling, which is 4 feet, which makes sense because this is an 8-foot wide porch. So I'm holding 4 feet of ceiling. Okay. I grabbed the tributary width. That's why I grabbed this, right? So the area that I'm responsible for here is this area, okay? That's the area that's loading this beam. Technically not the one that's like directly on top of this beam, but like that's not significant. So it's this area right here. This weight is going down to the right and sitting on this beam. The other side of this is going and sitting on the other beam, so I'm not concerned with it. So it's asking me for the tributary width to put into the software, so I'm going to give it that 4-foot number. Okay. Go back to here. Tributary width is 4 feet. It is perpendicular to the direction of the beam. Placement on top. My ceiling joists and rafters are going to sit on top of my beam. The dead load for the ceiling is 5 pounds per square foot, and the floor live or the ceiling live, whichever either way, is 10 pounds per square foot because there's no attic. Roof slope doesn't matter because this is a flat ceiling. If my ceiling was sloped, I could do that, but in this case, I'm going to write ceiling. This is the ceiling load. All right. So that's got the uniform load. It's going to do all that math for me. Great. I'm going to add a load. It's not a point load. I want uniform in pounds per square foot. It's on the full length of the beam. Now we're going to add the roof. Okay. So what's the tributary width of the roof? Well, wouldn't it be 4 feet, you might ask, because it's still half the porch? No, it's not 4 feet. And that's because there's an overhang. That is not the same distance. So what I'm going to do, instead of measuring this, because this is not the same scale, this is scale 8 inch, 1/8 is 1 foot, I'm going to happen to know that all my roof overhangs are 16 inches. So that's 1.333333 feet extra, or just 16 inches extra, right? So I'm going to go back to my math, and instead of 4 feet or 48 inches, I'm going to, so it's 1 foot and 4 inches that I'm adding on. So I'm going to go 5 feet, 4 inches is my new tributary width. Does that make sense? Because I need the projected area of the roof. I need to know this right here. That's the area that's loading my beam, which exists right here. That's where my beam is. All right. So that's why that's there. That's why I need to include that roof because it's there. It's weight. It counts for something. It's going to have shingles. It's going to have stuff on it. It's going to count for weight. So we'll switch back to here. All right. So that's why this one's a little bit wider. Placement is also on top. Dead load for a roof is going to be 10 pounds per square foot. The roof slope was a 612, so I'll put 6 in here. And the roof live load is 20 pounds per square foot. Call this roof. We got ceiling and roof. Awesome. So those are the two weights. We'll go back and look one more time. Is there any reason there would be any other weight on this thing? And the answer is no. However, if you wanted to be crazy, you could say, well, I plan on putting a bench on under this beam and attach it to this beam, a porch swing bench, and it's going to be made out of concrete and steel. So it's going to weigh a lot, and I want to account for that. So maybe in that case, you go back to your beam and you add some point loads if you're crazy. But you don't have to do that otherwise because the nature of the design is that there are live loads in here to anticipate that there will be temporary loads added and removed depending on the life of the house. So leave it alone. Unless you want that concrete and steel bench, then you can add it on. All right, so product selection. This is going to be commodity lumber because it's cheap and easy, and I can get it treated and protect it well on the outside of the house. 2x Southern Pine number 2. I'm going to wager that something that's only spanning 6 feet and only holding like 4 to 5 feet of tributary roof and ceiling, tributary width of roof and ceiling, man, I'm going to say 2 2x8s. Let's see how good I am. Oh, still over. It's still over. I didn't need that much. Okay. So in the world of beams, if you have something that's 2 2x6s and it's in a situation like that where it's kind of exposed and it's shaping the house, you really don't want to do less than 2 2x6s. So even though like I could do 1 2x6, it would be structurally adequate. Well, probably not actually. I'm at 61%. But this is totally fine. The deflection is basically nothing. So you might as well just, go with two 2x6s. If you want to do two 2x8s to make yourself feel better, you go right ahead. But in this case, I know this is sufficient. So I'm going to go back to here, and I'm going to add text two. This is how I write this. That means 2-ply, 2x6. Sorry, 6 Savannah pine. Wow, struggling. Number 2. Okay. 2 2x6 Southern Yellow Pine number 2. Rotate this, I guess 90 degrees ish. Okay, I'm going to put it right here next to this guy. All right, so that's good. That covers that beam. Control C, Control V. All right, copy this guy, put it over here. Now, I happen to know because of what I'm doing that this beam is about spanning maybe 7.5 feet. So it's spanning farther, but it's holding less. Now, if it was spanning the same and holding less weight, then I would think, if this one was already over designed and holding more weight, I'm just going to use it here because I know it's good. However, this is spanning farther, and the span of a beam has a large effect on how much it can hold. So we're going to calculate this one in the front. So we're going to add a new. I like to copy instead of adding a new just because it's a little faster. So I'm just going to hit the copy button. And this is going to be copy of, well, so this is front porch, right, left. Okay, member info, leave that alone, spans and supports. So this was an 8-foot wide porch. We're going to call it 7.5 feet because we're losing 7 inches because of those posts here. So the actual span that I'm talking about, the clear span from post to post, is in here, something like this, something like 7.5. So in here it looks like 7.1, but I'm going 7.5. I'm being conservative again. So 7'6" is our span. We have 2 columns. This part doesn't matter very much because there's not crazy loads here, but we're going to fix it, make sure it's all correct. All right, top edge bracing and bottom edge bracing. Okay, so the bottom edge is and supports only. There's nothing holding this. The top edge, well, let's think about what might be attached to the top edge of this beam. I think the answer is not much. All right, so what's going to be installed here? Well, we're going to have a ceiling joist right there, or somewhere like there. And we're also probably going to want some kind of blocking or something along this beam, or like a board turned flat or something, so that we can nail on whatever ceiling thing. Like it's not sheetrock because we're outside, but if we use like a fiber cement panel or something and wanted to nail it on as paneling, we need edge nailing right here. So what's going to happen is some kind of paneling is likely going to go over the ceiling of this porch, and it's going to end up getting nailed and sort of helps add rigidity to this beam on the top edge. So I'm going to account for that. And this kind of stuff doesn't matter over this kind of short span, so it doesn't not make a huge deal anyway. It's for like big beams where the bracing really matters. But I'm going to say full length. It's continuously braced because it's going to get a bunch of nails to a bunch of stiff material. Great. All right, loads. All right, so here's where we got to get funky. What kind of load is this thing going to be holding? So when we are doing something like this, we got some trusses here. We're going to get kind of odd in that the way this is all framed, everything's kind of connected to everything else in this little spot. So we don't really know that, oh, exactly this area is going to this beam and exactly this area, is for this side, like is for, this beam. It would be this wide, something like this. We don't know that that area is for that beam. Well, that part doesn't matter. It would be this part. So it's like, it's kind of being silly. It's all connected to each other and it's all sharing the same weight. But we're going to try to get close and we're going to be a little bit conservative because what's usually going to happen here is that I get a fairly small beam anyway, even when I'm conservative. So what weight might this be holding? Well, in terms of ceiling, the only ceiling this is responsible for is going to be, well, none, because the ceiling is sitting on the left two beams, left beam, right beam. Okay, so I'm not concerned with ceiling. If I wanted to be super technical and I knew my ceiling was 24 inches on center, I would know there's 12 inches, but that's not going to make hardly any difference in the design of my thing. So I'm going to neglect that. So no ceiling. What else might this be holding? Well, the roof. Yeah, there's an overhang here. There's an area here that's not being accounted for. One thing to think about when you are, if you were to do these tributary areas for all the things you're designing, so I now have a left and a right beam done. If there's an area that has not been accounted for, you ought to think about what the heck is going to hold that thing up. What is it, a wall? Is it something you don't need to calculate? That's fine. Just know that you need to think about, well, what's holding that up if it's not, if there's nothing, everything I've done hasn't accounted for that, then what should be accounting for it? So in this case, I have this guy here. So I'm going to be conservative and I'm going to say I want 2 feet of tributary width. I'm going to go in this direction and say, approximately 2 feet or so of roof along my beam. I'm holding that, maybe, because I got some overhang. All right. Well, the dimension's wrong because this is a 1 and 1/8. But I have a 16-inch overhang. I'm going to say 3 feet. Let's say I had a 2-foot overhang and then a foot back. I'd be conservative. I could say 3 feet. It's not going to matter anyway. So I have 3 feet. The reason I copy is because these loads are already here. Ceiling and roof. All these numbers and slopes are already populated. So I don't have a ceiling, so I can get rid of that. Okay. So I have 3 feet of roof. Slope is still 612. That's still good. What else is going to sit on this? Well, we're not done yet. And the reason we're not done yet is because there's something else adding weight to this that you have not seen yet. Okay, so I'm going to do a front view of this guy right here. So there's a post, there's a post, there's a beam that's dropped, and then there's a gable wall. And what's going to be on that gable wall, everybody? I don't know. How would I know that? Well, I'm going to look at the drawing. What's right there? What is this? That's James Hardy siding, probably. Well, it's Hardy. Yeah, Hardy lap siding. Okay. I'm putting siding on this. Siding is not light. It has weight to it. In this small of an area, it doesn't really matter, but it's got some weight. In a larger area, you got to account for that. So how would I do this? I'm going to show you how to do this just for the education, just for the learning. All right. So I've got siding. I got to figure out how much weight this is going to add to my beam. Well, the first thing is it's going to be a tapered load, right? Because there's not much siding over here, and there's more in the middle, and there's not much over here. So we're going to have a tapered load here. It's going to be kind of cool. So I need to figure out the approximate dimensions of my taper. I really just need to know my height here, because I know this is just in the middle. So what's the height of that thing? Well, this is all scaled. So all my elevations are scaled. So I'm just going to take a dimension and say, I'm going to go all the way to the peak. I'll be conservative. And the bottom of my beam is the plate line. So I'll go to there and I can't read it. So I will try to drag it out where I can read it. 2 foot, 10 and a quarter. Let's say 3 feet. All right. So we got a peak of 3 feet at the top, 3-foot tall wall. All right. So how do we do this? I'm going to add a load. It's not a point load. It's not a uniform load. It's a tapered load in pounds per square foot. Is it on the full length? Yes, it's on the full length. Well, actually, here's how this is going to work. We're going to do not the full length, and then we're going to do half of this. This is approximately 8 foot 1 inches. Half of that is 4 feet, 0.5 inches. Okay, so the tapered load is going to consist of half of it, and it's going to have tributary width from 0 to 3 feet. All right. So I'm going to go back to the drawing, and so you can follow what I'm doing here. Okay. This is 3 feet at the peak. What I'm trying to tell the computer is, it's sort of weird to think about here because the wall is a vertical thing, and the taller the wall, the more weight. But I'm describing it in a horizontal way, right? So when I do the roof and I'm talking about tributary area, I'm always looking down. I'm like, well, how much weight am I looking at in terms of the area this is holding? Well, the wall is right here, right? And it's not like I wouldn't look down to know if it was more weight. So if I had an even, let's for some silly reason, let's say I had a 5 foot tall wall on top of this beam. Okay, that would look the same on this plan, on the roof plan, right? That look the same as a 10 foot tall wall. Well, how do I account for that? Well, basically what I'm going to do is I'm going to take the height, and that is my width. It's my tributary width because it's trying to get in a load area, right? This is my loading area. It's going to take the pounds per square foot number that I say the wall weighs. It's going to take that width and multiply it by it, and it's going to apply that in the pounds per linear foot to the whole length of my beam because it's a, well, in this case, tapered load, but if this case was flat, it'd be uniform. So that's what I'm doing here. We're going to use the tributary width rule in order to establish the height of the wall. Now, how much does this wall weigh? I believe the number for a wall assembly like this is 6 or 7 pounds per square foot. We're going to go with 8 pounds per square foot. Should be a little conservative here. But these numbers are just kind of previously established. They're in tables and charts and things that I can share just from other books and things. But you could do the math and figure these things out if you knew densities and things if you really wanted to. But we're just gonna go with 8 pounds per square foot. So for every square foot of wall area that I would see from the front, there's 8 pounds. So I'm just trying to figure out how many of those I have here. And what I'm going to do is I'm going to use the software and I'm going to tell it, hey, by the way, from the left end to the middle, I go from no height to 3 feet of height. The weight's sitting on top of the beam, and I have a dead load of 8 pounds per square foot. There's no slope involved here. I'm not concerned with that. And there's no live load because we don't put live load on walls. It's not, it doesn't, we don't, no, we don't do that. The walls are just dead. They just sit there. We can walk on roofs and we can walk on ceilings. We can walk on floors, but we don't walk on walls. All right. So that is that. This is the gable wall. This is the gable wall left. So because of the way these tapered things work, I got to do 2 of them. So I'm going to copy this one because it's already close to correct. Full length, and instead I'm going to say it goes from 4.5 inch to 8.1 inch, and it goes from 3 foot tall to 0. See what the picture did up here? It's accounting for that little bit of extra dead weight from the wall. Now, it scales, this color scales the amount of weight we're dealing with here. So you can see that the amount of weight added from the wall is like not much compared to the actual height we're getting and the weight we're getting from the roof weight. So it's insignificant. But we're doing it so I can explain the principles of how you can do fancy loads on this. So product selection. Let's see if 2 2x6s will do it. Yeah, it will. We're at 54% here. We're not going to break it, and we have barely any deflection. Not even going to see that. Board's probably going to be like not straighter than 1/10 of a foot in the whole thing. 1/10 of an inch. Sorry. 0.15 inches. Yeah. Okay. So we'll go back here, and we know that's all good. And as predicted, I promise I think I know what I'm doing. This beam is just going to be like that. It's still over designed. We're still solid here. All right, so that's good. Moving on. Let's do this ridge. This one's going to be pretty easy. And I'll tell you why. It's because it's only holding one thing. Okay, so I'm going to copy this guy. And this is going to be the living room front to back. There's only one beam in living room front to back. Okay, code minimum, great. Spans and supports. All right, so let's go back here. What's our span? Is there any dimension on here that tells me that already? Okay, so I got a 16'4" from here to the end of the wall. So I'm just gonna be conservative. Well, I'm gonna do it exactly. Okay, so 16'4" from here to the outside of the wall, and I have a 2x4 wall, so 3.5 inch thick wall. So 16 feet and a half inch is my exact span. So let's put an exact span in for once. 16 feet, 0.5 inches. exact span. Don't worry about the weird load in this stuff right now. Okay, we are supported by a stud wall, spruce pine fir, stud wall, probably spruce pine fir. The selection of these species doesn't matter a ton, so don't fret too much. Okay, it's going to be laterally, but it's going to be blocked on one end, blocked on the other end, lateral support on each end. Great. Top edge bracing is going to have the rafters sitting on it, so it's going to be every 2 feet. There's a rafter, and the bottom edge is just going to stick out into the room, so end supports only. Loads. Let me draw that real quick just so it's clear. The section of what's happening right here looks like this. Beam, rafter, other rafter. Okay, so this is unsupported, and this is being hit by rafters every 2 feet. That's what I'm talking about. So, loads. All right, we don't have taper loads. We only have one load. Here's how we're going to do it. Pretty simple. There's no ceiling in this room, right? There's just a vaulted ceiling. It's just a roof. Great, and my beam's in the middle. So how would we do this? Well, what's tributary area loading this beam? Well, it's halfway between the beam and the support on this side to halfway between the beam and the support on this side in the whole length of the room. Blink, looks something like that. That's the area that this beam is holding. What's the width of that area? Well, it's pretty much half the width of the whole building, which is 20 feet. So yeah, we're going to be conservative and say yes, 20 feet, even though it's a little less because of wall thicknesses. So 10 feet. Boom. We got 10 feet of tributary width of roof. 10 feet tributary width of roof and roof. Okay, roof slope 612. Now there is a slight difference here, and that is that when we do a 10 and a 20 for a roof assembly, we're normally assuming the roof assembly is like the shingles, because these numbers can deviate depending on what materials you're using if you're looking at a special chart. But you got shingles, usually 2x6 rafters, and the OSB or plywood, whatever's on the roof sheathing. And then that's it, because you have an attic and you're not covering that up. But we're adding sheetrock to that because this is a vaulted ceiling. So what I'm going to do is I'm going to be over design, and I'm going to say, we're going to include the 5 pounds per square foot that a ceiling could be, even though that includes all the 2x6 rafters or 2x6 ceiling joists as well. So we could probably maybe do 12 and a half if we wanted to, but I'm going to be super, conservative here just because, I want to be safe. But that would be, I'm going to account for that extra weight because it's a vaulted ceiling. All right, that's it. 10 feet wide. Cool. Probably can't get away with commodity lumber here. We used 4 2x12s. It's probably not going to cut the cheese. Yep, failed at 130%. That's not going to work. Okay, so we're going to jump up to some LVLs because we like to install small things at a time. We're going to go 11 and 7/8 because that's a good, decent small size, frequently easy to buy. And if we use 2 of them, 1 3/4 by 11 and 7/8 LVLs, then we don't break, we don't crush the ends, and our deflections are okay. They could be better. Right now, the dead load deflection, which is the difference between this number and this number, is about 0.3 inches. So it's a little over 1/4 of an inch. That's not the end of the world, but we could do a little bit better. Let's try to get the total deflection under 1/2 an inch. That's better. All right, so now we're good. Okay, so 2 14-inch LVLs, that's going to be a minuscule cost difference, a little bit of improvement in stiffness. It's a little bit safer. It's not going to break. Yeah, we're good. We like that. So we're going to go back to the plan. And we're going to label it. 2 plies of 1 3/4 inch by 14-inch LVL. That is our label. Right there. So that's what that beam is going to be. All right, so let's look at this guy. Let's think a little bit about this beam before we jump in and design it. This front porch beam, which was spanning 8 feet, was over-designed at two 2x6s. Two 2x6s, yeah, and holding a little bit of wall and a little bit of roof. This guy is spanning 8 feet, and it's only holding a portion of wall with sheetrock on it. So, and no roof, because the roof rafters are going from the ridge to the wall. They're not sitting on this thing. So, and the ceiling joists are going left to right, so it's not really holding any ceiling either. We can presume that two 2x6s will be sufficient here. But we're going to check because, it's a good example and good practice. And it's going to be another example of how to use the sheetrock wall thing. So let's design this guy. So it's got an 8-foot clear span. Let's go ahead and go into the software. All right, I would call this guy, there's the only one in the kitchen, so I'm going to call it kitchen, right, left. Even though it's between the kitchen and the living room, you call it whatever you want. All right, span was 8 feet. It's supported by walls, blocked, top edge. Okay, bottom edge, let's call it nothing. There's not much supporting this thing. All right, all the way through the span at least. Loads. Okay. What weight are we holding? Well, we're not really holding any ceiling, but we are holding a little bit of wall with sheetrock. So how would we do that? Well, we're going to do another tapered load because, and it's going across the whole length, because the pony wall that's on top of this thing grows taller as it gets closer to the center of the house. So how do we know how tall it is right here? We know that it's going to be approximately 6 feet tall. Is that what we found out with the roof? When we did that math? 5 feet tall. Remember we did the triangles and it was like two similar triangles. We had a 6 and 12, but our house was actually, that's right, it was 5. It was actually a 10 and 5. So we know that 5 feet is the height of this thing in the center. Where'd my mouse go? It's the height of this thing in the center, but we're not drawing in the center. So I could do one of two things. I could try to figure out exactly what that number is, or I could say it's 5 feet and be conservative. Because what I'm doing here is I'm claiming I know, here's what's going on here. This is all the way to the center of the room. Our beam exists. It's going to be a raised beam. Our beam exists right here, and we're holding that piece of that pony wall. We're not holding this, but we know this is 5 feet, right? That's 5 feet. So if I just assume it's 5 feet without doing any math and make my life quick and easy, then what I'm really designing is this, which is slightly more weight. But I happen to know it's not going to make a difference because this thing's going to be over designed anyway. So I'm going to make my life quicker and easier and over design this thing to speed up the process because I get to do that. All right. So we're going from a tributary height of, it's got a 5 foot on the side and 0 on the other side. Okay, that's our load. It goes from nothing up to the top of the pony wall. The wall, it's going to the weight sitting on top. The dead weight of the regular sheetrock wall is going to be 5 pounds per square foot. There's no slope, no live load. Wall. All right, ta-da, product selection. Let's go pick out 2x Southern Pine number 2, 2-ply 2x6's solution. Oh look, 13% capacity, basically no deflection at all. Man, am I good. Okay. So this guy, believe it or not, is fine. We could probably use a single ceiling joist, but like I said before, we don't really want to do that when we have a thing like this because it might get smashed. It might not be a straight 2x6. You never know. And when you put them together, they end up straightening themselves out usually better than just by one by itself. All right. So there's my beam there. What else do I got? I got these on the back. Well, I'm going to use my brain of knowledge to speed this process up. And I'm going to look at this back beam and say, okay, it's spanning about 8 feet. I did the one in the front. It was an 8-foot patio, sorry, 8-foot porch, two 2x6s. It was over-designed. It was holding some wall and some roof. This guy is also holding a little bit of roof overhang and a little bit of gable wall as well. In fact, it's holding just a little bit more gable wall because on the other one, the wall did this, and on this one, the wall does this. So I've got all this, I've got this little bit of extra area up here. Now, here's what I think. This extra area is getting heavier closer to the support of my beam, which means the closer I get to the support, the less it matters. If I have a beam like this, and I put all the weight right here, I don't, the beam doesn't care because the weight's going straight through it into the post. All right, so I'm going to make an assumption that this guy is fine to be double 2x6 as well. All right, so I'm gonna drop another label right here. Good to go. Now this guy is new. This is different. We haven't done this one before. 8-foot span, but it's holding a bunch of roof and a bunch of ceiling. So let's figure out how much. Let's design that one. Patio, front back beam. Let's do that. Okay. Patio, front to back. Spans and supports. It was an 8-foot patio, I believe. Yep, 8-foot patio. I'm being a little conservative by saying it's a full 8-foot span. That's okay. And remember, looking from the right side, that's support 1, that's support 2. So support 2 is a post. It's a column, if you want to call it a column, probably Southern Pine. All right. Top edge is going to be supported by the rafters every 2 feet. The bottom edge is going to be hanging on the ends, nothing, end supports only. Loads. All right, let's delete this. So let's make it uniform, pounds per square foot. All right, so I got ceiling. How much ceiling do I have? Well, I'm going to go back and think. I'm holding about that much area of ceiling because the other side of the ceiling is going off to the right towards this wall right here. So how wide is this? Well, it's half the width of the patio. The patio is about 8 feet wide, so I'm holding about 4 feet. So 4 feet of ceiling. It's going to sit on top of my beam. The dead load of ceiling is 5, and roof live load, or sorry, ceiling, floor live load is 10. No slope. We'll call it ceiling. Boom diata. Move on. We're going to call this roof, and let's figure out what a roof is. All right, so over on the roof plan, this would look something like, okay, the area of our patio was something like this, okay, something like that. So the area of our tributary area that's sitting on this beam, I shouldn't use this color, but whatever. All right, so my tributary area that I'll draw in red is going to be all the weight that's sitting on that beam, which is going to be this. Because, where's my tool here? Okay. So halfway between the beam and the ridge, that distance is what the rafters are. Well, it's the measurement is wrong because it's scaled differently, but that's about 10 feet from my building, right? So the rafters go from the wall to the ridge, and they're supported at the ridge. So I only care about half the weight of the rafters coming and sitting on my wall, and I care about the overhang. So what do I need to know? I need to know the width of this, and the width of this, just like we did the front porch, is going to be the same. Well, it's not going to be the same thing because this wall is not the same here. So the distance between my ridge and my wall is 10 feet about, because the whole building is 20 feet and the ridge is in the center. Okay, so 10 feet from here to here, which means half of that I'm responsible for. So 5 feet. I got 5 feet of tributary width I'm holding on one side, and I have a 16-inch overhang on the other side. So I'm going to add 5 feet, and I'm going to add 16 inches. Okay, so I start with 5 feet, and adding 16 inches is adding 1 foot and 4 inches. So 6 feet, 4 inches. The rafters sit on top of the beam. The dead load of a roof is 10. Slope is 6, 12. There's no floor live load. There is a 20 pound per square foot roof live load. Okay, labeled as roof. There's all my weight. There's my span. Gonna pick out the product. I'm going to say maybe 2 2x8s. See what happens there. I got a little more weight on this one. Okay, I'm at 76%. That's fine. and I have very little deflection. That's cool. Let's see what happens if I do 2x6s. I'm probably failing. Yep, it's not strong enough. So this is why we got to check. All right, 2x8s would be good. So if this was me and I was building this, I might also make this other beam that's already 2x6s. I might make that 2x8s as well, because what's going to happen is if I make this 2x8s and not 2x6s, these aren't going to be the same height when they're covered up with trim. So it's going to look funny. So that's probably, I'd also just go in here and say, you know what, I want it to look the same. So 2x8s. And I happen to know that it's structurally totally cool. All right. So we are going to, this is getting to be a long video, so I'm going to end it. We're going to be done with the beams.